This short video aims to summarize an honours research and development project undertaken throughout the 2021 academic year as part of NGen 582. This project focused on the design, development, and testing of a novel robotic hand and associated machine vision-based control system. Taken for granted by most able-bodied people, object manipulation is a complex operation that is essential for almost any human task. As robotics and automation continue to advance, tasks which are traditionally done by humans are becoming increasingly automated, inevitably leading to the need for robots to perform human-like grasping. For simple objects, a parallel gripper may be used, and for applications with consistent object geometry, a purpose-built gripper may be used. However, if a general-purpose end effector capable of manipulating any object, or more complex manipulation such as tool use is required, a highly dexterous manipulator with many degrees of freedom is needed. Given that humans demonstrate exceptional object manipulation and dexterity, and that we want robots to interact with human systems, it follows that the form of such a dexterous manipulator should follow that of a human hand. This project aims to design and develop a robotic hand that can demonstrate human-like movement and grasping. To aid the testing and validation of the hand prototype, this project also aimed to develop a novel control system which would enable the hand to copy the hand position of a person in real time using machine vision. The human hand uses approximately 21 degrees of freedom to perform object grasping. To produce a feasible prototype, only the most critical of degrees of freedom are replicated. The design has 6 degrees of freedom in total, 1 for each finger and 2 for the thumb. 4-bar linkages allow other joints to be moved in a human-like manner without adding to the number of actuators required, acting as a sort of mechanical tendon. Each degree of freedom is actuated by a micro DC geared motor. Aside from the fasteners and electrical components, the design is fully 3D printed, with all pin joints being printed in place, allowing for simplified assembly and a great reduction in part count. The input to the control system is a video feed from a basic computer webcam. MediaPipe, an open-source machine learning framework developed by Google, is used to perform the machine vision. Using MediaPipe, a Python program was developed to identify the contraction angle of the 6 joints in the hand which corresponds to the 6 degrees of freedom in the prototype. These angles are converted to motor positions, then sent to an Arduino microcontroller via the serial port. The microcontroller is then able to perform position control based on this incoming data to track the target hand in real time. As shown in the demonstration, the control system was able to keep up with the real-time inputs, tracking the hand almost perfectly. The design was also validated in its ability to grasp a number of objects in a human-like manner, as shown by these renders. Pursuit of the ideal human-like robotic hands remains an important goal for automation, human-machine cooperation, and prosthetics. This project was successfully able to demonstrate a low-cost yet capable prototype by making use of mechanical underactuation and 3D printing synergies, in addition to a novel control strategy that allows for rapid and real-time testing of robotic hand systems without the need for specialized equipment.